Page 37. Copernicus. That puts us in the 14 to 1500s. So first some basic outline. He's a Polish astronomer. And church deacon. He comes up with the first comprehensive, is that word again, comes out with the first comprehensive heliocentric model. That gets us to this idea. The Copernican revolution. And another important idea, very important idea, something called Ocams Razor. All right. Okay, so yeah, he was Polish. He was a worldly man, a very well-educated man. He trained to be a physician, I think in Austria. A man of many talents. He was a church deacon. Some accounts have him as a priest. But the important part is that he was in some fashion or another a church official. That's the important piece. He comes up with the first comprehensive, and there's that word again, heliocentric or sun-centered model. How does this happen? Well, he's a scholar. He was aware of Aristarchus's proposal. And that made sense to him. He believed that a much simpler model could be had to explain what could be observed. Now, I should also point out that we're still not in the age of the telescope yet. We're not there yet. So we're still using Mark 1 Mod 0 eyeball. Technology is still where it was in the time of Ptolemy. But he uses the same data points that Ptolemy used, and he came up with this heliocentric model that you see at the bottom of your page. Now, what made this model so compelling is this idea of Ocam's Razor. Okay, so here's the long-winded explanation of Ocam's Razor. If you have two competing, comprehensive explanations of an observed phenomenon that are equally comprehensive, such that the only difference between the two explanations is that one is a hell of a lot simpler than the other one, you go with the simple explanation. That's the one that's going to work. And this has been a piece of scientific thought for centuries now. We still abide by this idea of Ocam's Razor. Another way to think of Ocam's Razor is this. The scientific application of the KISS principle. What's KISS? Keep it simple, stupid. Remember, Einstein was entirely about the KISS principle. And yeah, this works. This works. Now, just as a little side note here in this age especially, this age of social media where you're being flooded with all sorts of ideas presenting themselves as scientific ideas, or choose your conspiracy theory. If you look closely, and we're going to get more into this when we talk about the scientific method, if you look closely at a lot of this stuff, it doesn't pass the KISS principle yardstick. It just doesn't. So Ocam's Razor, the scientific application of the KISS principle, and Copernicus comes up with a model like so. Sun, Mercury, Venus, Earth, and yeah, the moon does go around the Earth, that's true. Mars, Jupiter, Saturn. Now, why did I stop there? Well, because the other planets, Uranus, Neptune, Pluto, had not yet been discovered. You need a telescope to see those guys. All right, so these are the planets that we could observe. But look what we got here. Oh yeah, and stars out here. Look here. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have fewer than 10 moving parts, whereas the Ptolemy's model has over 80 moving parts. So there's such a dramatic and drastic difference between these two models in terms of their simplicity, and yet they are both comprehensive. They are both absolutely comprehensive. They both explain everything beautifully. This gets us to another concept that's very important for us to be aware of. This idea. The Copernican model was elegant. And when we say something is elegant in science, in math, what we mean is it is simple and comprehensive. Simple and comprehensive. That's what we strive for in science, is elegant solutions. Simple and comprehensive. Now, certainly Ptolemy's model was comprehensive, but it was certainly also not simple. All right? It was elaborate. It had over 80 moving parts. It was almost like a Rube Goldberg construction. And if you're not familiar with that reference, perhaps when you were a kid, you had that you played that board game Mousetrap. It's kind of on that idea. When you compare the two, the Ptolemy's model was more like the mousetrap game, whereas the Copernican model was like a mousetrap. Now, back to this idea of Copernicus being a church deacon, or as some accounts have, a priest. The point is, he is in some fashion or another a church official, and he was an educated man. Interesting guy too. By all accounts, a pretty good Joe. He was very well educated. He was a landowner and a landlord. There are many accounts that show that he was really quite a kind and generous landlord, and would never hesitate to help his tenants when they were in tough straits. He would, he'd step up and try to help folks out. He was a good guy. Overall, he was a good guy. But now we're into the 14 and 1500s, so we got to replay a little bit of history here. First, we began with the Greek influence in European culture, which was supplanted then by Roman culture. Now the Romans, you could make the case that the Romans were, in terms of their geopolitics, were quite astute in that when they conquered, they oftentimes would assimilate culture, and certainly that was the case with the Greeks. Greek culture was assimilated into Roman culture, and so as a consequence, the Greek god Ares became the Roman god Mars. The Greek goddess Aphrodite became the Roman goddess Venus, and so forth. And what comes along with the whole package? Well, the works of Plato and Socrates and Pythagoras and, yes, Aristotle, and the ideas of a geocentric universe. And so that's now part and parcel with Roman culture. What supplanted Roman culture? Well, the church. By this time, the church is the predominant cultural and political force in Europe at that time. Some folks might want to debate that, but we can make a good case for it. So, as this course of events transpired, and I want to be careful because I don't want to give the impression that we're church bashing here, and we're not. There's a lot of credit that needs to be had during this time. We're coming out of what were referred to as the Dark Ages. We're still at a time we're starting to get into kind of a reawakening of education and intellectual pursuit. But we're at a time when 99% of the people in Europe are illiterate. So who preserves all this culture during this time? Well, that would be the church. The church preserved the works of Plato and Socrates and Aristotle and Euclid and so on. Now we're at a point where this idea of geocentrism fits beautifully with any number of passages in Scripture. So much so that now this idea of an earth-centric or geocentric universe has now become doctrine. It's now church doctrine. To contravene that doctrine is to get yourself in a whole heap of trouble. Copernicus knows this. Nevertheless, he pursues his studies. He tells his family, quiet, don't say anything. And they do, they stay quiet. And he does write a book, but he holds off until shortly before he dies. How shortly? The day before. His book is published the day before he dies. What are you going to do to me? Kill me? I'm dying. So his book is published. It's not, the book is not banned, but it is condemned. But nevertheless, the genie's out of the bottle and the book is on the street. This is why we refer to this as the Copernican Revolution, not the Galilean Revolution, because it was Copernicus who laid the groundwork. And so he gets the credit. So we today live in the Copernican revolution. Well, what is that? Well, the Copernican revolution is when mankind has to face the fact that it's not the damn center of the universe, and that upsets a lot of folks. All right, so the next bit we'll talk about is Galileo. So we'll pause here, and then we'll go to Galileo.